Hello, friend, welcome. Today we are going to talk about what is a functional safety in the automotive. What are the skills needed to become the successful functional safety engineer? What is the role of the functional safety engineer? What are the skills and the tools you need to know in order to perform the functional safety jobs accurately? And if the functional safety is not done in the car rightly, what are the risks happens there? And lastly, what tools or software information you need to know to become the good safety engineer? And the very important thing, in the last, we will see which are the 50 questions asked in the interview to the functional safety engineer. So this is today's talk is all on the functional safety and its related things, friends. So let's start. What is a functional safety? Basically, this is used in the automotive safety and aeroplane safety everywhere, but we are talking today about the automotive functional safety. So, the automotive functional safety refers to the discipline within the automotive industry that focuses on ensuring the vehicles and their components operate safely, reliably, predictably, even under the potential hazardous conditions. It involves identifying potential hazards, assessing associated risks, and implementing the safety measures to mitigate those risks. Functional safety in automotive systems. Functional safety in automotive systems have various aspects, including electronic systems, softwares, mechanical components, and their interactions. It aims to prevent or mitigate the impact of failures or malfunctions that could lead to accident, injuries, or damage to the vehicle or its occupants. Key elements of the automotive functional safety. What are those key elements? Number one, risk assessment. Identifying the potential hazards and assessing the likelihood and severity is fundamental aspect of functional safety. It involves conducting hazard analysis and risk assessment, that is called HARA, to prioritize the safety goals and requirements. Number two, safety requirement engineering. Defining safety requirements that specify how the safety goals will be achieved is crucial. Safety requirement addresses aspects such as functional behavior, fault tolerance, diagnostic, and fail-safe mechanisms. Number third, safety analysis. Performing safety analysis such as failure modes and effect analysis (FMEA), fault tree analysis (FTA), and other methods to identify the potential failure modes, their effects, and the effectiveness of safety measurements in mitigating them. Number 4. Safety architecture and design. Developing system architecture and designs that incorporate safety mechanisms and features to achieve the desired level of safety integrity. This includes redundancy, diversity, segregation, and other design principles to enhance the fault tolerance and reliability. Number 5. Verification and validation. Ensuring that safety requirements are correctly implemented and verified through testing, simulation, and analysis. Validation activities demonstrate that the system operates safely under normal and abnormal conditions. Number 6. Documentation and reporting. Maintaining detailed documentation of safety related activities, including hazard analysis, safety requirements, verification and validation results, and safety cases. Reporting on safety related issues and compliance with safety standards is also essential. Number 7. Compliance with standards. Adhering to the relevant safety standards such as ISO 26262 is critical for ensuring that automotive systems meet industry-wide safety requirements. Compliance with standards provides a framework for achieving the functional safety and demonstrating regulatory compliance. Overall, automotive functional safety aims to minimize the risk of harm to the vehicle occupants, pedestrians, and other road users by systematically addressing the safety considerations throughout the development lifecycle of automotive systems and components. It is a multidisciplinary field that involves collaboration among engineers, designers, testers, and other stakeholders to create safe and reliable vehicles. What are some jobs in the area of the functional safety? In the automotive industry and related sectors, there are various job titles or the roles associated with the functional safety engineering. Some of are like this one. Number 1, functional safety engineer, automotive safety engineer, system safety engineer, safety analyst, safety consultant, safety manager, functional safety architect, functional safety assurance engineer, functional safety validation engineer, functional safety technical specialist, functional safety compliance engineer, functional safety process engineer, functional safety manager, functional safety coordinator, functional safety head, functional safety specialist, functional safety consultant, functional safety auditor. So these are some roles in that. So now let us see what are the risks in car if the functional safety audit, development and architecture not defined accurately. What happens? So if the functional safety is not defined accurately in the cars, it can lead to various risks that compromises the safety of vehicle occupants, pedestrians and other road users. So there are a number of potential risks associated with inadequate functional safety measures. So number 1, increase the risk of the accident. If the functional safety is not defined very well, not thoroughly implemented, failures to properly address the functional safety can lead to malfunctions or failures in critical systems such as braking, steering and propulsion, increasing the likelihood of accidents. Number 2, loss of vehicle control. Malfunctioning safety critical systems may result in loss of control over the vehicle, leading to collisions, rollovers, and other dangerous situations. Number 3, injuries to occupants. Inadequate functional safety measures can result in injuries to vehicle occupants in the event of accident or collisions due to failures in safety restraint systems such as seat belts, airbags, and child restraints. Number 4, pedestrian safety risk. Malfunctioning vehicle systems such as pedestrian detection and collision avoidance systems can increase the risk of accident involving pedestrians, cyclists, and other vulnerable road users. Number 5, property damage. Vehicle malfunctions or failures caused by inadequate functional safety measures can result in property damage to vehicles, infrastructure, and other objects in the vicinity. Number 6, legal and regulatory consequences. Failure to comply with functional safety standards and regulations can lead to legal liabilities, lawsuits, fines, and regulatory sanctions for automotive manufacturers, suppliers, and other stakeholders. Number 7. Reputation damage. Safety related accidents, safety related incidents, or recalls resulting from inadequate functional safety measures can damage the reputation of automotive companies, leading to the loss of customer trust and brand loyalty. Number 8. Financial losses. Safety related recalls, warranty claims, and legal expenses resulting from the inadequate functional safety can lead to significant financial losses for automotive companies. Number 9. Loss of market competitiveness. Safety is a key factor influencing consumer purchasing decisions. Failure to ensure the adequate functional safety measures can lead to loss of market competitiveness and reduced sales. Number 10. Impact on the innovation. Inadequate functional safety measures may hinder innovation in automotive technology as companies may prioritize safety compliance over the development of new features or capabilities. So, basically, ensuring accurate and effective functional safety measures in cars is crucial for protecting the safety of the vehicle occupants, pedestrians, and road users, as well as maintaining the reputation of company and competitiveness. So, you have seen now the risk if the functional safety is not performed very well. So, now let us see, friends, which tools or software systems or information you need to know to become a successful functional safety engineer. So the important thing to become the functional safety engineer, you need to know the various tools and softwares used in the field of the functional safety engineering can greatly help you to become the more effective with efficiency. So which are those key tools and software you need to know to become the great or the successful functional safety engineer? Number 1. Requirements management tool. This is very important. Tools like IBM Rational Doors, JAMA Connect, or Siemens Polarian System Viewer are commonly used for managing safety requirements, ensuring traceability, and facilitating collaboration among team members. Number 2. Risk assessment tools. Software such as RELX, Atom Toolkit, or PHA Pro is often used for conducting hazard analysis and risk assessment, HARA, FMEA, fault tree analysis, and other safety analysis techniques. Number 3. Modeling and simulation tools. Tools like MATLAB, Simulink, DSpace, System Desk, or Vector Canoe are used for modeling, simulation, and testing of safety critical systems and components. These tools enable engineers to simulate various scenarios and assess system behavior under different conditions. Number 4. Safety analysis tools. Software such as Medini Analyze, SCADA Suite, or LDRE tool suite is used for performing the safety analysis, including software safety analysis, reliability analysis, and safety verification. Number 5. Fault injection tool. Tools like Fault Injector, INCA, or Vector Canoe can be used for injecting faults into the system during testing to assess their robustness and fault tolerance capabilities. Number 6. Version control systems. Familiarity with version control systems such as Git, Subversion, or Perforce is important for managing changes to safety-related documents, source code, and other project artifacts. Number 7. Automated testing tools. Tools like Jenkins, Selenium, or HPALM or QC are required for automating the testing processes, including unit testing, integration testing, regression testing, to ensure that safety critical software functions correctly. Number 8. Safety lifecycle management tools. Integrated tools suite such as Siemens Team Center, Polarium, ALM, or PTC Integrity are designed to support the entire safety lifecycle, from requirements management to verification and validation, and can be streamlined compliance with safety standards such as ISO 26262. Number 9. Documentation tools. Tools like Microsoft Office Suite, Word, Excel, PowerPoint, LaTeX, or Altation, Jira, Confluence are commonly used for creating and managing the safety-related documentation, safety cases, and reports. Number 10. Programming language. Proficiency in programming languages such as C, C++, Python, or MATLAB or embedded C are often required for developing the safety-critical software and conducting analysis or testing. Number 11. Safety critical software development tools. Tools like MISRA, C, C++ Checker, LDRE, or Coviety are used for ensuring the compliance with coding standards and detecting potential software defects that could impact safety. Number 12. Communication tools. Collaboration and communication tools such as Microsoft Teams, Slack, or Zoom are essential for coordinating with team members, conducting meetings, and sharing information effectively. So these are the tools and the softwares or the skills you need to know to become the good, successful functional safety engineer. So now friend, let us see what are the skills, the bullet points you need to know for being the functional safety engineer to perform the job. So basically, you should have the deep understanding of the safety standard. It means a comprehensive understanding of the safety standard, which is ISO 26262 is essential. This includes familiarity with the standard requirements, pipeline, guideline, and best practices for achieving the functional safety in automotive systems. Number 2. You should be able to do the risk assessment and the analysis. Proficiency in hazard analysis and the risk assessment HARA techniques is crucial, and if you know this skill, the HARA analysis, this increases the ability to identify the potential hazards, assess their likelihood and severity, and prioritize them based on the risk levels. Number 3. You should be able to gather the safety requirements engineering. Strong skills in defining, eliciting, and managing the safety requirements are necessary. This includes translating the safety goals into specific requirements, ensuring traceability throughout the development lifecycle. Number 4. You should know some safety analysis techniques. For example, having the knowledge of various safety analysis techniques such as failure mode and defect analysis, fault tree analysis, and others are important. Being able to apply these techniques to identify the potential failure modes and assess the safety measure is essential and critical. Number 5. Verification and validation. You should have the knowledge about how the verification and validation happens of the functional safety and what are the methods used for this testing, simulation, and analysis techniques to ensure the safety requirements are met, verified, and analyzed. Number 6. System engineering. System engineering is a very key because this functional safety deals with different systems, multi-systems. So understanding the system engineering principles and practices is necessary for integrating the safety considerations into overall system design and architecture. Number 7. Technical expertise. Strong technical skills in the areas such as electronics, software engineering, and mechanical engineering are beneficial. You should understand how the car works, how the systems work, how the functions work. That's very important. This enables the functional safety engineers to understand the interrelations of the automotive systems and components. Number 8. Problem solving skill. This is very important. If you know the problem, you have to have the very root cause finding attitude so that for any problem you think critically and propose the effective solutions considering the overall system design. Number 9. Attention in detail. Functional safety engineers must have the very attention to the details to identify the potential safety hazard and ensure the safety requirements are accurately met, defined, and implemented. Number 10. Communication and collaboration. Effective communication skills are crucial for collaborating with cross-functional teams and conveying the safety-related information to stakeholders. These include the written, verbal communication, and discussion, technical and functional safety reviews. Number 11. Regulatory compliance. Knowledge of regulatory requirements and standards related to automotive safety is important to ensuring the compliance of the functional safety is legal with the standards defined by the governments or the agencies. Continuous learning. Continuous learning about the functional safety is constantly evolving, and so it is important for you to know the latest trends, functional safety, cyber safety, collaboration, and so many things. So these are the skills or the knowledge you need to have in order to become or in order to implement the correct functional safety. So basically, what are the roles of the functional safety engineer? What generally they do? So functional safety engineers, compliance and standards. They make sure compliance and standards are implemented throughout their functional safety architecture from the start to the end. The risk assessment. They conduct the hazard analysis and risk assessment. Safety requirement definition. They define the functional safety requirements. Safety analysis, safety verification, validation, documentation, and collaboration. So now, friends, we saw it. Now the important thing, let us see, if you are going for the interview of the functional safety position, what are the questions will be asked to you? So these are the 50 questions you should prepare or study about these questions so that you know each and everything about the functional safety. You get the overall understanding how the automotive works, how the functional safety can be implemented. So let's start spread. So number 1, what is the ISO 26262 and why is it important in the automotive functional safety? This is first question. Question number 2, explain the concept of the functional safety in the automotive industry. Number 3, can you outline the key phases of the automotive functional safety ISO 26262 lifecycle? Number 4, what is the purpose of the safety goal in ISO 26262? Number 5, describe the difference between the ASIL levels in the ISO 26262. Number 6, how do you determine the automotive safety integrity level ASIL for a system? Number 7, what are the main components of safety case? Number 8, how do you perform the hazard analysis and the risk assessment, which is called HARA? Number 9, what methods are commonly used for safety requirements elicitation? Number 10, how do you ensure that safety requirements are traceable throughout the development lifecycle? Number 11, explain the concept of ASIL decomposition. Number 12, what is the purpose of a safety element out of context? SEooC. Number 13, describe the concept of safety mechanism and their role in achieving the functional safety. Number 14, how do you perform a failure mode and effect analysis, FME? Number 15, what are the different types of fault tolerance mechanisms? Number 16, how do you access the diagnostic coverage in safety critical system? Number 17, can you explain the concept of safe state in the automotive systems? Number 18, how do you verify and validate the safety critical software? Number 19, what is the role of fault injection testing in functional safety? Number 20, describe the difference between the random hardware faults and systematic faults. Number 21, how do you ensure the safety of communication protocols in automotive systems? Number 22, what is the purpose of the safety validation plan? Number 23, explain the concept of safety integrity levels in the context of ISO 26262. Number 24, how do you handle the safety requirements changes during the development process? Number 25, can you discuss the role of safety culture in an organization? Number 26, describe the key features of a safety culture in an automotive development team? Number 27. How do you ensure that safety requirements are implemented correctly in the software development process? Number 28. What are the challenges of integrating safety critical systems with autonomous driving technology? Number 29. How do you manage the safety requirements in a multi-tier supplier environment? Number 30. Can you explain the concept of single point faults in automotive safety? Number 31. What is the difference between the safety goal and the functional safety requirement? Number 32. How do you perform a safety analysis for a complex system with multiple interacting components? Number 33. Describe the role of safety audits and assessment in the development process. Number 34. What are the key considerations when selecting the safety mechanism for a system? Number 35. How do you assess the impact of software updates on the functional safety? Number 36. Can you discuss the role of the safety standards other than the ISO 26262 in automotive development? Number 37. How do you ensure that the safety requirements are met in agile development environment? Number 38. Describe the process of safety validation testing for a new automotive system. Number 39. What is the purpose of a safety validation report? Number 40. How do you manage the safety related documentation throughout the development lifecycle? Number 41. Can you discuss the role of fault tolerance in achieving the functional safety? Number 42. How do you ensure that safety requirements are adequately addressed in supplier contracts? Number 43. Define how do you do the functional safety design reviews with the suppliers. Number 44. Describe the concept of safe state handling in automotive systems. Number 44. What is the role of the safety manager in an automotive development team? Number 45. How do you ensure that safety critical components are properly integrated in overall system architecture? Number 46. Can you explain the concept of common cause failures in functional safety? Number 47. Describe the difference between the safety goals and system level requirements. Number 48. How do you perform a safety assessment for a legacy automotive system? Number 49. What are the key challenges in achieving the ISO 26262 compliance? Number 50. Can you discuss the role of the safety standards in shaping the future of the autonomous vehicles? So friends, this is what the top 50 questions can be asked to you, and this, if you prepare for these questions, then definitely any kind of the interview will be able to crack it, because understanding behind the system, the functional safety, the overall product development, it makes the sense. And today we covered all things on the functional safety, including what is the functional safety, what are the risks if you don't do the functional safety in the car, what are the job types of the functional safety, what are the skills needed to become the successful functional safety engineer, what are the roles of the functional safety engineer, what are the questions of interview used for the functional safety engineers, and what are the key components of the functional safety. So ISO 26262 is the automotive functional safety standard, friends, and based on that all the functional safety is defined. So today we saw this automotive functional safety standard and all the related things to it. So thank you very much for your time, friends, to listening to it. If you have any questions, feel free to put comments in the comment box. We'll come back to you, friends. So we are the data plex. Share the value, share the knowledge, and create the value. Thank you very much, friend. See you in the next knowledgeable sharing the value video, friends.